All right. I have a little story to tell you. Okay. So, I think we mentioned at the very first video that you watched. I graduated from the University of Missouri, and the main architecture, like the well-known architecture, is the column like that. There are 6 columns in here. Okay, and so I went for a PhD. Right, so go to a PhD program, do some PhD research, blah blah blah. One of my side project in the PhD research, so I deal with the something related to DNA, and then you probably have heard the DNA have that. If you look at the just structure right here, so we have a sugar phosphate. There's a phosphate group. There's a sugar ring connected to a nucleobases, where adenine, guanine, thymine, all those thymine right here, cytosine, right? And the 2 strands, so they exist as double strand DNA. These 2 strands have a nucleobase. They hook up with a hydrogen bond. We'll learn that later. Okay, so that's how they stick together. Anyway. The sugar that you probably are familiar with, there is ribose sugar, right? So it's a 5-membered ring, or a glucose, which is 6-membered ring. I'm sure you're probably familiar with that. The sugar in DNA, this guy right here, similar to ribose, but this position right here does not have an OH group. See that? This carbon right here has no OH group, All right, we call this a deoxyribose, and deoxyribose is at position 2, so position 1, position 2, so we call 2-deoxyribose right here. All right. One of my side research, just like a little small amount of PhD research that I did, involved this step. So I want to put the benzyl bromide right here onto that oxygen. All right. So put this guy right here onto that oxygen. So oh, sorry, not this oxygen, these 2 oxygen. Put it wrong. It's been a while. Put on these 2 oxygen. Look something like that. All right. So I'm adding benzyl bromide with a 2-deoxyribose, adding a base, sodium hydride. All right. We have THF, it's a solvent, tetrahydrofuran. RT, anyone can guess what RT stand for? Room temperature. Okay. So add a reagents, add a base, add a solvent, and let them react at room temperature. Want to have 2 moles of benzyl bromide get on these 2 oxygen. Look like that. All right. I calculate the theoretical yield of this reaction is 100% yield, maximum percent yield. I should get 15.3 grams. Okay. Now, the first time I do this reaction, one reaction takes a while, so I have to do reaction for like about a couple hours, and then have to. When you get the product, you still have to do some column chromatography or separation, because you have to separate the product from anything else, and that takes like 2 to 3 hours. It's a while, takes a while, right? So that's a grams that I got. That's actual yield. That's low, right? That's real low. I expect to get something close to 15.3. You're not going to get exact 15.3 because you're going to lose it somewhere, maybe on a glassware, maybe, when you transfer the product, you're going to lose some yield. But at least I probably expect to get like maybe 12, 13 grams. But I got only 0.21 grams. All right. Help me real quick. So I have to talk to my advisor. Okay. This doesn't work. Doesn't give you a lot of ground here. This is horrible. I'm going to report him in percent yield. Right? How many percent of this compared to 15.3? All right. So we have the formula right here. So the actual yield over theoretical yield times 100. I want you to pause the video right here, get your calculator, and plug in here. What's the percent yield here? All right. If you've done that, so 0.21 grams put on here, over theoretical yield, so I supposed to get 15.3 down here, times 100. I get 1.39% or something, 1.4%. That's low, right? So I talked to my advisor, okay, it doesn't work. What do you want me to do? My advisor, this reaction is supposed to be simple. We look up the literature and other people have done it, but not like this, but similar to this, but it works just fine. Right? So something probably wrong in this reaction. So you have to go check it. right? So I just go change. All right, maybe let's try add catalyst. Let's see how it goes. So TBAI, I don't remember. It's been a while. So that's one of the catalysts. So put in here, do this reaction again. Everything else the same. Keep everything the same. Just add this guy TBAI. I got percent yield 0.20 grams. That's still low, about 1.4%. I mean, nothing different. All right, try to do something else. Let's try heat it up. So change the room temperature, elevated temperature, heat it up the reaction. I got 0.31 gram, a little bit better. So if you do the percent yield here, it's probably 1.7% maybe. I mean, it's still low, right? Try to add a change. Maybe the solvent, something wrong with the solvent. So change the from THF to DMF, different type of solvent. Worse. But I mean, it's not really worse. 0.2, 0.3, 0.18, but that's nothing different. Okay. So this is my work about a week, right? Next week, come back in here. Well, I mean, I don't know what to do. Looks like, adding catalyst doesn't work. Solvent doesn't work. Temperature, not a problem. Nothing different. Well, we might need to check the benzyl bromide that we use, if it's actually benzyl bromide, because the bottle is old, could be there for like 10, 20 years. Who knows what's in it, right? So I go check it. That's take a few hours. So check. Well, benzyl bromide just look as good as new, right? What about the other reactant? Maybe something wrong with this. So to get to this point, I have to go through a few process, and maybe going along those process, maybe this guy is not really what we think it is. So I go check it. Well, I found out that it's 98% pure. It's really, it is. So, do this reaction again, 0.2 gram. I don't know what happened. It's 2 weeks later. I still don't get anything. Well, I have checked everything except one thing I haven't checked yet. What is that? The base. I haven't checked sodium hydride yet. I haven't checked using adding catalyst, checking the solvent, checking the temperature, check the structure of the reagent. Nothing happened. I haven't done anything with the base yet. That's the last thing that I did. That's at the end of the second week. I've been doing the same reaction for 2 weeks now. Nothing really happened. Well, go check the base, if it's actually the base. So, look up the literature. So there's a kind of like something you have to be aware of. So sodium hydride, can react with water in the air, like moisture in the air, and to form sodium hydroxide and hydrogen gas. Yeah, that's what happened. And hey, I didn't know that. I just used sodium hydride from the bottle that sit in the lab. I never used it before. I'm just trying using it. So I suspect that maybe sodium hydride is actually wet. That's what we call it. It's wet and becomes sodium hydride or decompose, whatever. So I do the filtration, add sodium hydride here, add all the oil, because it reacts with water. So I have to use oil, and clean everything. Make sure sodium hydride is dry. Right? And then use the new sodium hydride that I just washed, in this reaction. And here's what I got. 14.1 grams. Oh my God. I've been checking everything else except sodium hydride right here. Right? 2 weeks of work. Yeah, that's how I got. That was an unfortunate event in my research career. Anyway, so all right, 14.1 grams. So some of you you guys help me real quick. So calculate the percent yield for me real quick. All right, if you calculate percent yield, so 14.1 grams divided by 15.3 times 100, that's 92.2 grams. That's research experience. 2 weeks of work. Finally, I got this done. Yay! I was gonna cry. Anyway, so the moral of the story, I want to tell you. So the theoretical yield, we talk about that, which is the maximum amount of product that you can possibly get, or we can call it 100% yield, stoichiometric yield, have the full name, but we could call it a theoretical yield. Actual yield is what you actually get. Not always 100% yield. So you're not going to get 100% yield anyway. You will lose it all along the process. You add the reaction, you transfer the compound, you do a purification process. I mean, you're going to lose some of the percent yield, but I mean, not a lot. But we hope that we get the good reaction usually give you about 90% yield or higher. Okay. All right. So always less than the theoretical yield, always less. All right, so I'll have you do it right here. What is the percent yield of the glycerin? We just did together in the previous video. If the theoretical yield is 19.96, we did this together. We got this number. And the actual yield, let's say a student do this reaction and he or she get 15.0 grams of glycerin. What is the percent yield? All right, can you do that? Super simple. So 15 grams divided by 19.96 times 100 and get 75.2%. That's it. All right. Let's go to the next video.